Okay, so I'm going to proceed to random forest. So random forest is another popular machine learning algorithm that belongs to the supervised learning technique. It can be used for both classification and regression, but it's mostly used for classification. Yeah. It combines multiple classifiers to solve a complex problem and to improve the performance of the model. Random forest is a classifier that contains a number of decision trees on various subsets of the given data set and takes the advantage to improve the predictive accuracy of that data set. Instead of relying on one decision tree, the random forest takes the predictions from each tree, and based on the majority vote of the prediction, it predicts the final output. So as we can see from this graph here, the training set is separated into subsets. And each of subsets is going to be passed into one of the decision tree, and each of the decision tree is able to generate one prediction, and it's going to be like the majority of the vote is going to be the final prediction. And there are some assumptions for random forest. So since random forest combines multiple trees to predict the class of datasets, it is possible that some decision tree may predict the correct output while others may not. But together, all trees predict the correct output. So that means like maybe this tree is predicting like wrong one, but because this is like a minority, so we're not taking care of this. We don't really care about what this is, but we give like the one that's the majority. So yeah, it's still correct. Yeah, with two assumptions for this random forest. The first one, there should be some actual values in the feature variable of the data set, so that the classifier can predict accurate result rather than guess result. And second, the prediction from each tree must have very low correlation. So the prediction from this tree and all this tree should be relatively independent. And there are some advantage of using random forest. So first, it takes less training time as compared to other algorithms, and also it predicts output with very high accuracy. Even for large data sets, it runs really efficiently, and it can also maintain accuracy when large portion of the data is missing. So the last point is the main reason that random forest gets so popular. Especially for some of the data, you have a lot of missing values. Random forest is the one that it goes for. I'm not going to just read these steps. It's not really useful. Okay, so let's just jump into this example here. So suppose there is there's a fruit basket, and you're giving this fruit baskets to a random forest classifier, and the data set is going to be divided into subsets and give to each of these decision tree. And during this training phase, each decision tree is produce a prediction result. And when a new data point occurs, then based on the majority of the result, the random forest classifier predicts the final decision. So it's like when you have this fruit basket, you subset it into 3 subsets, and you give them to each of the tree, and these 2 trees predicted to be apples, and this one predicted to be banana, and then you take the majority, which is apple, so you predict this to be an apple tree. I mean, yeah, an apple. I think this example is actually not so good. So let's proceed to the better one. So this here I'm using the iris data set instead of, yeah, we're really using a real data set, the iris one. And we use the random forest. We first subset into training and testing, validation, and then we use the random forest to predict the species based on all variables. And we use 100 trees to do this. And after, and then we want to see how does our classifier do, how is our classifier doing. So we can see for it's got 100% for this Setosa, and it's also doing a pretty good job on this other two. So that kind of showing us that our random forest does work for this one. And then we test whether our random forest is doing a great job on new data sets. And we can see it indeed doing a really good job. It predicts this Setosa 200%, and it predicts the Virgi. Yeah, this one's also 100%, right? So yeah, also doing pretty good job on this one too. So it's saying that our random forest model is not only having a low bias, but also having a low variance. And now I want to just plot the ROC curve. So we can see we did a pretty good job too. Yeah, with the accuracy of 0.99, 0.9. Question?